Hi, good day everyone. So today we will be doing May-June 2025, number 10. May-June 2025. Which, as we know, number 10 is our vectors and matrices question, so let's go right into it. In the diagram below, OPQL is a parallelogram. OP is vector R, and vector OL is vector S. T is a midpoint such that PQ is equals to QT. The point M divides PL into ratios 2 to 1. So therefore P to M is 2 parts and M to L is 1 part. Right, let's just, and we know parallelograms, opposite sides, so therefore this would be vector R and this would be vector S. Now if we said PQ is equals to QT, then this also would be vector S. Right, so they said find in terms of R and S PL. So PL, so the starting point is P, ending point is L. We know PL would be PO. So starting point is P, so from P to O plus O to L. Now they already told us that OP is vector R. But are we going in the direction of OP? No, we're going in the opposite direction. So opposite directions is just negative or the inverse, right? So we know that PO is the opposite direction of OP. Therefore, PO would be R multiplied by -1, which is negative R. This is negative R. And OL is S, so we know that PL would be negative R plus S. Right, and that is how you do this question. Let's go on to the next one. They want OM. Is OM? Yes, they want OM. So OM, let's just zoom in here. We're going from O to L and then L to M, or we can go from O to P and P to M. Up to you. Now let's just discuss about this. So if we look at this, we know that how many parts is this in our ratio? This is 3 parts, right? So we know that PM PM would be 2 out of 3 parts of PL, right? Again, you have to make sure that they are in the same direction, right? Then we also know that ML will be 1/3 of PL, right? So after we have done this, we know that PL is minus R plus S. So we know that PM would be 2/3 of PL, which is minus R plus S. You could leave it like that if you want. And ML would be 1 1/3 of minus R plus S, which again we can leave it like that, right? So I'm just going to take this information and put it in the next question. Right, so I have PM and I have ML. So again, up to you what direction you want to take. We can go from O to L and then L to M, or you can go from O to P and then P to M. Again, up to you. I will go, I don't want to deal with negative or opposite in the opposite direction. right? So I will go from O to P and then P to M. Right, so this is O to P plus P to M. I'll do it the next way to show you guys, but it will be the same thing. Right, O to P is R plus P to M is 2/3 of negative R plus S. Let's reduce that. That's R plus negative 2/3R plus 2/3S. So R, that's a plus and a minus, So R minus 2/3 R plus 2/3 S would be 1/3 R plus 2/3 S. Right? If you want to, you can, which would be 1/3 open bracket R plus 2S. Right? If you want to factorize it or break it, put it into further simplification form, it would be this. Now, this would be your answer for OM. Up to you, whichever one you want to keep it. I think both of them you'll get it correct. If you do it the next way, which is OL to LM. So if we go from OL plus LM, we know that OL is S, vector S. We do know that. Right? Now, we know ML is this. Right? But because LM is going in the opposite direction of ML, right? This would be, you multiply this entire thing by -1. So LM would be, let's multiply this, would be minus 1/3 R plus S multiplied by -1, which would be 1/3 R minus S. Hold on, and this is in the space of that working, so let's just put this a different, let's put this up here. Right, so we know again that ML, I'm gonna multiply it out, minus 1/3 R minus, not plus 1/3 S. So LM would be the opposite direction. So I'm multiplying everything by -1, which would be positive 1/3 R minus 1/3 S. Right? So it's going to be, yeah. So I'm going to plus 1/3 R minus 1/3 S, group like terms, so it will be 1/3 R plus S minus 1/3 S. 1 minus 1/3, because although we're not seeing this is 1S, right, is 2/3 S, so it would be 1/3 R plus 2/3 S, which when we factorize it, it will be 1/3 by R plus 2S. So again, doesn't matter which way we go, we will get the same answer. Right, it's up to you, but you do have to remember, if it's going in the opposite direction of my arrow, of what the vector is, the direction of the vector, you do have to multiply by -1 to make it the opposite. Right, now the next question here is prove that OM and T are collinear. So to prove that they are collinear, you have to prove that two vectors, right, with a similar point are, what is the word? Scalar multiples of each other. That is what I was looking for. So we already have OM, so I won't even try to, I'll use OM, right, and I can use OT, or I could use MT, up to whatever you want to do, right? So OT would be OP plus PT, which we know is 2S, right? So OM is equals to third R plus 2S, and OT is equal to OP plus PT plus PT. We know OP is R plus PT, although you're not seeing it. P to Q is S and Q to T is S. So how many S's is that? That's 2S. So plus 2S. Right now, we can already see it here that to OM is equals to third of what is OT, R plus S. So because they are scalar multiples of each other, they are collinear. They all lie on the same line. So you would say that OM is equals to a third of OT, and they are collinear, or something along those lines, right? And that is how you would do this question here. Now let's do part B, which is our matrices question. They said, let's zoom in. So there are three matrices, A, B, and C. Find matrix A, B plus C. Then they said find the inverse of A. Then they said write a 2 by 2 matrix that represents the product of A by minus A. Now, if we look at this, A by A inverse cancels out each other, right? So there is a rule for this, which is, right, so A by A inverse, although I'm not even doing it, I can do this question very quickly. A multiplied by A inverse is equal to an identity matrix. I don't have, this is one mark, so it shouldn't be that much working, right? An identity matrix is 1 0 0 1. You can multiply it if you want, but again, this is one mark. You just need to know that a matrix multiplied by its inverse gives you an identity matrix, such as I, right? An identity matrix is always 1 0 0 1, and that is how you would do this question here. Right, so all we have to focus on is this last two. So first off, they want to find AB plus C. So AB means to multiply A by B, and then you plus in C. Oh, okay. This is, so anytime I have matrix that I have to multiply or anything like that, I like to put the order of a matrix. So A is a 2 by 2, 2 rows by 2 columns. This is 2 rows by 3 columns, and again this is 2 rows by 3 columns. They said find AB, alright, so let's see if, so A by B, A is a 2 by 2 and this is a 2 by 3. I like to see if it is conformable to multiplication, which just means that is the number of columns in your first matrix, such as A, and the number of rows in your second matrix in multiplying B are equal. If they are conformable to multiplication. So A by B would be 3, 2, 5, 4 by 4, 0, 2, 3, negative 1, 7. Now, my number of columns in my first matrix by number of rows in my second matrix will be my answer. So this will give you a 2 by 3, which means I have 2 rows and 3 columns. So I'm just going to put it like this. This is row 1 by column 1. This is row 1 by column 2. This is row 1 by column 3. Row 2 by column 1. This is row 2 by column 2. And this is row 2 by column 3. Alright, that is how it will look. 2 rows by 3 columns. Now you can use this to calculate. So E11 is row 1 by column 1. So this is the way you can do it step by step if you don't know how to multiply quickly. If you do, you can do it the other way, which I'll do both ways. So E11 is row 1 by column 1. That's 3 by 4 plus 2 by 3. E12 is row 1 by column 2. That's 3 by 0 plus 2 by negative 1. And E13 is row 1 by column 2. That's 3 by 2 plus 2 by 7. Right, and then 2-1 is row 2 by column 1. That's 5 by 4 plus 4 by 3. Yeah. E22, that's column 2 by column 2 by row 2. That's 5 by 0 plus 4 by minus 1. E23 is 5 by 2 plus 4 by 7. Alright, so finding each element and just fill in. 3 4s are 12, 12, and 3 2s are 6. That's 12 plus 6. Then 0 minus 2. Then this one is 3 2s are 6 plus 14. 20 plus 12. 0 minus 4. 10 plus 28. Alright, so this would be 6 and 12 is 18, negative 2, 20, then 32, negative 4, 28 plus 10 is 38. Right, and that should be your answer. Now the next way to do it, I don't know if I'm kind of running out of space, is you take your row by column. It will give you just this row by this column, then this row by this column, then this row by this column. You do the same thing. So you will get the same thing here. I'm just showing you how you can figure it out just by using these elements. Right, and that is AB. Then you have to add C. Right, let's do the last part, which is the addition part. So when we are adding, let's just go down. They do have the same number. They do have the same order, so we can add them, right? One of the rules of thumb for addition of matrices, they must be of the same order. Right, so AB, which is 18, negative 2, 20, 32, negative 4, 38, plus 4 minus 1, 2, 7, 3 minus 5 is equals to 18 plus 4, negative 2 plus minus 1, 20 plus 2, 32 plus 7, minus 4 plus 3, and then 38 plus minus 5. 18 and 4 is 22, minus 3, 22, 79, 39, minus 1, and 33. And that should be your answer for this. Find the matrix AB plus C. Right, okay, and that is how you do this. Now let's find the inverse of A. The formula for the inverse of A is 1 over your determinant multiplied by your adjoint. Alright, so let me first get A. This is what A is. And let's just make that a little bit bigger. Alright, I'll call this A, B, C and D. Right, so it is 1 over your determinant, which is AD minus BC, by your joint, which is you interchange D and A, and then you take B and C and multiply by -1, so it'll be negative B, negative C. So that's 1 over AD, which is 3 4s are 12, minus BC, 5 2s are 10, by, this is 4, 3, and then -2, -5. That is 1 over 2 by 4 minus 2 minus 5, 3, which would be a half of 4 is 2, a half of -2 is -1, -5 over 2, and then 3 over 2. Right, which is 2, -1, -2.5, and 1.5. And that should be your answer. You could put 0.5, up to you, but that is how you would do this question right here. Right, and well, we did the last question, which is, if you were to take this, the inverse, A, and multiply it by A, you will get this. Alright, that is just a rule that you have to learn. You can do it if you want, but this is 1 mark, so I won't spend too much time on this. And that is the end of May-June 2025, number 10.